security from that perspective. And while we were doing that, we also said, let's build DNSSEC in from the start. Let's make sure we make a design that is where we can do DNSSEC. That was the first product that we built. That was NSD. It's still out there. It's used by a number of big TLDs. It's a authoritative only high performance name server that is useful in certain circumstances. It's definitely not useful for all kinds of enterprises and very dynamic environments and act as a master server there, but it is very good as a secondary authoritative server. Unbound was the same story. Unbound, we figured there's only one real high performance implementation that people can grab from their shelves. And maybe people will not go to DNSSEC if they cannot build a resilient environment, if they cannot have two code bases providing functionality to their customers, critical functionality to the customers. If we want DNSSEC to happen, we really need to offer that choice. Hence, we need to develop a product which is up to market standards, to what people actually need, and DNSSEC needs to be an integral part from that. And so we cooperated with VeriSign, Nominet, KeyRAI, and EPNet, who had built a prototype in Java. So a low performance, but a fully functional name server that did DNSSEC that was used in the protocol development phase. We took our experience for NSD, and we built a name server that was high performance. One of the conscious choices we made in doing so was to license that under a BSD license. That means you can freely pick it up, you can modify it, and even implement it in your product without having to disclose the add-ons that you make that are proprietary. So there was a conscious choice on our behalf to say, whatever we developed, it can become closed source at the point if there are companies that actually want to pick up a piece of software and implement it so that they can roll out DNSSEC more efficiently and faster. They don't have to do their own development. And I think that we have seen a little bit of success there, because there are a couple of products in the market that have picked up our code base and have extended it and put it in their machinery. So you now can go to a vendor and buy a product that does DNSSEC, which has our software under the hood, and we believe that's a part of success in offering tools to make deployment actually cheaper, because those companies who incorporate that software don't have to do their own research and development. Same goes for OpenDNSSEC, and OpenDNSSEC is something that is still under development. And I think that is an important tool, so I want to highlight it a bit. I'm going to switch over all these slides that have to do with other parts. But OpenDNSSEC is a product that has been mentioned before. OpenDNSSEC is, again, something you can freely download. You can just get it from the net, install it in your environment, and go and run, if it fits your needs. It has been developed in cooperation with KeyRAI, with .SE, with Nominet, with Synodem, which is a small consultancy firm from Britain. SurfNet, it's the academic research network in the Netherlands, and SIDN, it's the top-level domain administrator for .nl. What we set out to do there is create open source software with a BSD license, again with the intention that if people want to commercialize that product, simply because there are parties that will only buy commercial products, that was the reason for the choice for BSD license. I lost my sentence here. Anyway, the goal was that it was simply to integrate into existing structures. So the cost of implementing DNSSEC is actually low. We're not quite there yet with that design, but it's good enough to integrate in the infrastructure of, say, .uk and .se at the moment. It's not yet good enough for any enterprise to go into that, but we have a roadmap there that will get us there. It's built in a very open fashion with all kinds of modules and components that can be replaced. One of the things that we found very important in this design was the way that you can store keys. There are many organizations where storage of a key on a smart card or storage of a key on a disk is more than sufficient for security needs. But for instance, for TLDs or for high-end corporations, there might be security policies that require storage of keys in temper-hardened hardware, such as FIPS for accredited machinery or certified machinery. So that is one of the modules that we chose to be very open, and people can just plug in their own requirements there. What we set out to do is to have a bump in the wire. For people who understand DNS architecture, what we actually want to have is that people who have now a master server that spits out zones to secondary servers, we want to have something that you can put in between that master server and the other machine. So in a sense, move your infrastructure just a little bit so that you don't have to worry about redoing your provisioning system and such. It's something you can just put in between and magic will happen. We're not quite there yet, but 5 minutes should be more than sufficient. Again, the intention here is openness, and I won't go into the architecture, but what you see currently is that there are many people who have taken this approach to build software and tools and make those available freely just to lower the initial cost of deployment. That goes for tools, that also goes for documentation. People who have been involved in writing documentations on several levels, on specification level in the ITF, in open documents, also in operational documents. Anna-Marie gave an example about forgot the name, the policy documents. What? The practice statement, yes, that's what was I referring to. And there is a bunch of slideware and things that people make available. So if it comes to this, the very early deployment costs, those have been carried by organizations that actually act in the benefit of the public interest. Privately funded sometimes, publicly funded sometimes, often charity foundations. IEC, for instance, is a charity foundation, and Nelnet Labs is a charity foundation. With no commercial interest whatsoever. We give away this stuff for a good cause. Now, I believe that Russ has an inventory of tools that Sparta has made and an inventory of also other material, so he will go into the details.
So do you know where the presentations are?
I have no idea, but let me see if I can find something. Minimize that. Oh, yeah. It's the folder over there. Is that this folder? No, this is Open Office. Presentation. Cybersecurity. There. Wednesday morning, Thursday morning. Yep. Open source tools.
Okay.
And you have the thingy. Okay. Please.
Thank you. Well, thanks, folks. Glad to get a chance to tell you about some of the tools we've done. Thanks. Oh, thank you. Some of the tools that we've done and the survey that we've conducted about all of the DNSSEC capabilities that we've been able to find and identify that are hanging out around the net. This information in this slide set is open source information from the surveys. There are some products too that I just didn't put in the slides for the survey. But got a lot to go through, so I'm going to, this worked yesterday. Okay. Please, is there a switch? Great. Okay. There's actually many ways to draw what a DNS service looks like, and this is one that we use. It helps divide up what functionalities are done and give some names to those functionalities, because often these get blurred together. And one of the most common places that they get blurred together is a registrar and a name server operator. Many people think of them as completely and totally integrated. You shouldn't think of them that way. You heard some about this yesterday and why. And this talk is really about completely separating them and is focused primarily on the name server, user, recursive server, moving parts of DNS. So on the far left, you see Zone Administrator. That's the entity that actually controls the content. And I think most of the folks probably heard my soapbox on it's the content that counts when it comes to DNS. So it really all starts with the Zone Administrator in terms of the content. The authoritative name server administrator is that activity that actually is responsible for the operation of the name servers that sit on the internet and serve the data. A recursive name server administrator is an entity that runs a name server that goes and gets information, goes and fetches answers. And of course, the client is the user. So before a client can get the information about a www.example.com out of DNS, it has to be put into DNS by the zone administrator. So that's kind of the flow that I'll be talking about and covering the tools here. Now, the difference between what we're doing without DNSSEC and what we're doing with DNSSEC in the simplest case is that the signed data, which is additional content that's contained within the zone, is created in some manner by the zone administrator, passed into the authoritative name server, and then a trust anchor that is needed for the verification of the information needs to be obtained somehow in the validating recursive name server. And so in sort of the simplest case, that's all there is to it to do DNSSEC. Well, in reality, that's not all there is to it, but that's the simplest point of where we are. Now, in the DNSSEC tools suite, there are a number of tools. This work has been funded largely by DHS, S&T, and it has been funded from the beginning to produce open source, and again, it's also a BSD license, decision consciously made. And people have incorporated this. They certainly have also taken some of the ideas, put it into their products. There is no cost monetarily for any of the licensing at all. And so the basic purpose is to make DNSSEC easy, at least as much as possible. And so the DNSSEC tools website is there on the slide. And this is what the DNSSEC tools website looks like when you go to it with a standard browser. And you can see there's some of the divisions, often groupings of the tools that I'll talk about here. And so when you go ahead and incorporate some of these tools, we have tools already that let you put those pieces in. Now, the functions that you have to put in include key maintenance, zone signing, provisioning of your equipment, parent-child communications, and a batch of other things there. Additional troubleshooting, we have some tools for that. So let me just zippy right through these. I've divided them up into groupings of tools, and I'll get to them quickly in order. I'm not going to talk about very many specific ones, just to give examples of how the tools fit in. So for a zone administrator tool, there's 4 that are targeted primarily at them. And there the 4 are, and that's basically where they fit. So the zone signer, in some ways, is similar to the open DNSSEC effort to not exactly be bumping the wire, but to be available for easy signing of the zones and automate it and make it as simple as possible. And Mapper and Donuts allow you to look and see if you've done your tools right. And RollerD takes care of making sure you keep things signed, that you renew your signatures, and that you re-sign things as necessary. And these are just a few more descriptions. The slides, Andrea did say, will be up on the website so we can pull them out. Anybody that is interested in more detail, I certainly can provide them. So there's the 4 tools. This is one of the interesting ones where you can actually graphically look at the state of the zones that you care about, and it will give you the status in a visual manner of where your information that's relative to DNSSEC is and what state and life it is. Each of the colors and lines mean certain things. Now, the authoritative server tools, these are people that are actually operating the name servers per se that are authoritative for a particular zone. And the tools you see here are also the same tools that are available and used by some zone administrators. So I won't go into the details on them, but it shows that the tools can be useful in multiple functions. So when we get to the validating recursive server tools, that's where you're going to get answers. You know, what's the IP address for www.google.com? And so there you have to have trust anchors, and you have to manage those trust anchors. And the tool for that is called TrustMan, and it is aware of the RFC that talks about how you go about rolling over trust anchors. So you can put that in place, and if you decide to set it up this way, never have to look at it again as long as everybody follows the RFC. And well, you'll probably have to look at it sometime, but routinely you don't have to do anything to get your updates. The DNS packet flow and logwatch are a couple of other tools so you can see what's going on, some of your troubleshooting for your administration. And let me just get up to the DNS packet flow. And for folks that remember the CNN slide and taking 100 queries to fill it, that was done with DNS packet flow. That's one of our tools that do that. Logwatch, anybody that's operated name servers or other service functions know there's a huge amount of logging data. And this is a tool that's aimed specifically at pulling out the DNSSEC parts that are indicative of problems or potential problems or pending problems. End user tools. There's a couple of categories that are available to run in end user systems that in general aren't very visible to what we talked about in the earlier session. I think the concept of sort of the end user not wanting to know anything about how this network works, it just needs to work. And then you've got DNSSEC enabled applications. One of the ongoing discussions in the DNSSEC world is how much and when and how necessary is it to actually get DNSSEC validation clear to the end user. And there's not certainly 100% agreement on what should happen there, but the beauty of the DNSSEC design is you do not have to have a ubiquitous single answer. Different organizations, different individuals can do things different ways. So, and all of these are clear over on the right. Now, the libraries for validating, that was something that was used under the code that was running on the Firefox yesterday. That was the tool